Well, hello Internet, and welcome to part 1 of my C# video tutorial. You guys told me you wanted to see a C# Xamarin and game tutorial series, and this is where it's going to begin. In this part of the tutorial, I'm going to provide an introduction so that you will know how to install C# on Windows, of course, as well as on Mac OS. And I'll also cover a lot of basics like input, output, data types, strings, functions, looping, and a whole bunch more. Like always, all the code is available in the description underneath of the video, and I have a lot to do, so let's get into it. Alright, so I'm mainly going to be developing on Windows, but I didn't want to leave the Macintosh people behind, so if you want to do absolutely everything I'm doing here, instead of downloading Visual Studio, which is what we're going to do on Windows, instead you're going to download Xamarin at xamarin.com, download, and all you do is type in your name and your email address and a company, agree to the terms, click on download, it installs, and everything's great. Once you install it, this is what you're going to see, and if you want to create a new project, just go up here to File, click on New Solution. This is on Mac OS, but like I said, I'm going to be developing almost everything in these tutorials using Windows. Doesn't matter, everything's exactly the same. Then you're going to click on .NET, and for now, Console Project, and then click on Next. I'm going to call this Sample App, and I'm going to click on Create. And just to show you that everything's going to work, here is everything right here. And if you want to run this guy, you just come up here, click on that guy right there for the play, and you can see that the console opens and runs. All right, so there you go. Mac users, that's what you're going to do. Now on to the Windows users. Now on Windows, I am going to be using visualstudio.com, and I'm specifically going to use Visual Studio 2017, which is the release candidate. And I trust you'll be able to download this. Just click on free download, install it, and it will be ready to go. And now I'm going to jump over and start writing a whole bunch of code. Alright, so here we are in Windows, specifically Windows 10, and if you want to create a new project, just so you know, you're going to come over here, click on File, you're going to say New Project like that, and it's going to open up. Once again, to start off, we are going to have Visual C# right here like that, and we are going to click on Console Application, and you're going to give it a name. And I'm going to call this guy C# Tut. Like that. That is going to be the name for it, and I'm going to click on OK and create everything. Alright, so after you do that, this is what you're going to be presented with. A whole bunch of different things. These are going to be a whole bunch of different libraries that are going to provide objects and different functions that we will be able to use. They are very useful, and this is what will open up whenever you create a new project. Now up here where we see a namespace, you're going to use namespaces to define globally unique objects so that if you combine your code with other people's code and the names are exactly the same, you're going to be able to use this as a way of making your code unique. Class program is the default name that we have here for this guy. And like always, a class is just going to define the variables and methods used by objects. And I'm going to get much more into classes and objects in a later part of the tutorial series. Right here you see the main function, which is going to be where all the execution begins. Whatever code is inside of these two curly brackets is where everything's going to start off executing. Specifically, static right here means that this function is going to belong to the class and can be executed without needing to create an object. Don't worry if you don't know anything about objects, I'm going to get into them heavily. Void just means that this function doesn't return a value after it executes. But it is very common to, instead of having void here, have int inside of there, and in that situation it would return an integer whenever this function's done executing. That integer value would normally be a 0 whenever the function successfully executes, or -1 whenever an error of some sort occurs, but we're going to keep this as void, and once again just means it doesn't return anything. And the main function here also, as you're going to see, is able to receive multiple values that will be stored in a string array, and an array is just a whole bunch of boxes that contain values. What we're going to do here first is just a standard old hello world, just to make sure that everything is working. So I'm going to go console, write line, and if we would use write, it would not put a new line at the end. If we put a write line, it will put a new line at the end. So let's just come in here and we'll demonstrate exactly how that works. Right, like that, and you save it, and you click on start, and it executes. And like I said, Mac OS users are going to be able to automatically do all the same things. But what did we see there? It opened up, but then it closed. Well, a trick to keep the console open after whatever code we have inside of here executes is to come in here and ask for input of some types. And the input we're going to ask for is just whatever. It's just going to be a return key. And to do that, we're going to put read line inside of there and save it and start it. And now whenever the console opens, it will not close until I hit return. And you can see right there, it says hello world. All right, so we can hit return. It received input right here into this guy right here, and it closed the application. We're going to actually get real input here in a moment, though, so that you'll get to see how we can input information and then work with it. Now, like I said right here, the main function is going to be able to receive a certain number of arguments that are going to be passed to it. And if you want to simulate passing command line arguments into Visual Studio, what you're going to want to do is over here in the Solution Explorer, that is what this guy's called. What we're going to do is we're going to right click on this, and then we're going to come down here and select Properties. This guy's going to open up right here, and right here where we have debug, we're going to put a couple values. So I just put 1 with a space, 2 with a space, 3 with a space, and 4. All right, so that's all we're going to need to do, and we can keep that open. We can save it, do whatever, jump back over inside of here. And if you're wondering how to pass those properties into Xamarin also, what you're going to do is go over here and right click on this, come down here to Options, and then inside of here, click on Default, and then type in the same arguments right there, and click on OK. And just to test that that works, we can go in here, create a for loop that's going to run through every single one of those passed in and print them out. Click on this guy, and you can see it printed 1, 2, 3. All right, back over into Windows, demonstrate some more stuff. All right, so I'm going to go in here and do exactly the same thing. And what we're going to do is we're going to loop through those arguments, and I'm going to explain what's going on. So I'm going to first off create a variable that is going to increase in value each time, an incremented value, and it's going to be an integer. And I'm going to continue incrementing as long as the value of I is less than the total number of arguments that are in our array. And that's how we get that. We use the length field to get that information. And then remember, we have to increment. Now, I++ is exactly the same as if I would go I is equal to I plus 1. All right, it's just a shortcut way to do exactly the same thing. Once again, we're going to come in here and we're going to go console, write line, and remember, write would not have a new line. And let's go and do something a little bit better here. What we're going to do is we want to actually print out the specific, what it's called, index for the array item. And we're going to go and print those out as we print out the values stored inside of them. Now, arrays are going to assign values that are called indexes. And that is how we're going to be able to get the value stored inside of each of the boxes inside of our array. And the very first index or address for the value in our arrays by default in C# is going to start at 0. So what I want to do is I want to come in here and not only get that value, but I also want to go and print out the value associated with that index. This is going to be the first value that's going to be transported into this final string, and a string is just a series of characters. So if I want to get the value of I get I right there. And if I want to get whatever is stored inside of the arguments array, I just go like that. And then what I'm going to do is whenever this runs, it's going to take I right here and put it right there inside the string. And where it has 1, it's going to take this and put that right there. So if we save this and run it, you're going to see it does exactly that. See, argument 1, 2, and 3, and it prints out the values that are going to be stored inside of that guy. But it's missing one of those values, and that's because I had this assigned to 1 instead of 0. So let's run it again, and you're going to see how the indexes work out and how the values associated with those indexes in the array work out and print our information. All right, so there we are. Now we know how to use a for loop inside of C#. If you are wondering if there's other ways to get the array from in regards to the command line arguments that are passed in, we can actually create our own string array, and we just do it like that. And the little brackets there mean it's an array instead of just a simple one string. So I'm going to call this my args, and you're probably never going to do this, but I thought I'd cover it just to be covering everything. And what you're going to do is go command line args, and this is a capital G, command line args, and this is a method that will actually pass those values back to us. Now let's say I wanted to print out all of those arguments onto the screen as just one big giant string. I could go right line, and I'm going to use a function called join. So string dot join, and I'm going to join every single value inside of that array together, and I want each of them to be separated with a comma and a space. And then the array that I want to use here to output this information is my arguments, which is this guy right here. And we can run that to see if that worked out for us, and you can see that yes indeed it did. However, what it also does is it prints out the location for your actual executable file. And the benefit of that is now you know on your specific computer where the executable is for your application that you are making inside of C#. So kind of useful information nonetheless. So now what I'd like to do is cover functions, and functions just allow us to take our code and break it up into smaller and smaller pieces, because you don't want 100 lines of code that you can't read. You want to try to keep it to about 10 lines of code per function. And what I'm going to do is I'm going to create a function that is going to be called say hello, and it's going to receive input and then send a message to the user. So I'm going to get outside of my main function and create a new function, and I'm going to have this be private, and I want this to be void. It's not going to return anything. Static, of course, means that it belongs to our class. It's not going to receive any arguments. As you can see, there's nothing inside of there. And then inside of it, what we're going to do is, well, let's first off go and create a string, and let's have this be name, and let's give it a default value of nothing. And then we're going to output some information on our screen. So we'll go console, and here I'm going to use write because I do not want a new line after this gets put on our screen. I'm going to say, what is your name? Put it like that, and another space so that it looks nice and neat. Then I'm going to ask the user for information, and I'm going to store that in the string that I created above. So how we can do that is go console and read line, and whatever they enter is going to be stored inside of this name string variable. And then what I'll be able to do is go console, and now I'm going to use a write line, and I'm going to go create a little bit more of a fancy type of hello world thing. And we'll go hello, and then I want whatever the value of name is to be transposed directly inside of there and print it on the screen. Now, however, if I want to call this from my main function, because remember all the execution starts in the main function, I'm just going to go say hello and put that there and run it. Now, as you can see, it prints out all that other information. I can type in Derek, hit enter, and it now says hello Derek. Okay, so that's how to get information as well as how to print it out. And we don't need all this right now, so let's just delete that. Okay, so now I'm going to talk about data types. And data types are very important because you want to use as little space in memory as humanly possible so that you don't use up a ton of memory, and also so that your application can run as fast as possible. Now, to start off, probably the most basic type of data type are what are called booleans. And they only store values of either true or false. So I'm going to have a boolean here, and it's going to be can I vote, and I'm going to mark that as true. There you go, you just created a boolean, and of course you could have false in there instead, but nothing else. And then we have integers, and they are probably going to be the variable data type that you use more than anything else. And what they represent are 32-bit signed integers. And you may ask yourself, well, what exactly does that mean? Well, let's go, and I'm going to print out the largest type of integer that you can possibly have. So let's go biggest integer. And these are just going to be values that don't have decimal places in them. And to get the maximum value an integer can store, you go int and max value. And why not go and also find out the smallest value you can have? Remember, these are going to be signed. So we will go smallest like that. And to get the smallest, we change this to min. And if we save that and we execute it, you are going to find out exactly the biggest integer you can store and the smallest integer. Of course, you can't store anything smaller or anything bigger than those guys. If, however, you would like to store something bigger, there are also things called longs. And longs are 64-bit signed integers. and they are just going to have a long there instead of an int. So let's say we wanted to find the biggest long, like that, and you define integers, of course, by typing in int. Okay, so that's exactly like we did with the booleans there. We're going to do more with variables as we continue. And let's go and get the largest long we can have, and let's go and get the smallest long we can have. And now, with a click of a mouse, you can see the biggest long and the smallest long. All right, so very, very, very big numbers. That brings us to decimals. Now, decimals are going to store 128-bit precise decimal values, and they are going to be accurate to 28 digits. And I'm going to show you an example here of how those guys are going to work for us. So let's go and create a decimal. And to do so, you just go decimal, and I'm going to go decimal pi value is equal to, and let's throw pi inside of there, and I want to make sure you see the m here. You're going to have to put the m inside of there whenever you define decimals. So there we have a decimal pi value. Then what I'm going to do to show you how accurate these are, I'm going to go decimal, and decimal big num is equal to, and I'm going to throw in this number right here. So let's put that at the end of it, and then let's try to add those together and see what it looks like. See how accurate they are. So I'm going to go console and write line, and I'm going to say, make sure that you can see that this is a decimal, and I'm going to go pi plus big num is going to be equal to, and 0 inside of there. And then you can also do addition inside of here. You don't just have values inside of there. So we can go decimal pi val plus, and then decimal big num, and close that off. And why don't we come in here and also print out the biggest decimal value we have. So we'll go decimal like that. And to get the maximum decimal, we're going to say decimal in uppercase letters, and smallest decimal as well, and decimal again. Got all those saved. We're going to learn all kinds of things here, and here you can see. Now we added 3.00000 and a whole bunch of ones. You can see right here the value is 32, and we added 1 at the end of it. You're going to see that the 1 got on there, but the next one is going to be the next one over, and it's just completely disregarded. And if you count all these numbers up, you're going to see that there are 28 digits. So you will know that the maximum precision in regards to working with decimal values for a decimal data type is going to be 28 digits. And you can also see the biggest decimal and the smallest decimal. Now we're going to come in and work with another data type that is called doubles. And to create a double, you just go double like that. And this is a 64-bit floating type, and that just means that it has decimal values inside of it. And let's come in here and let's change this up a little bit because they're not as precise as decimals. So basically this is where we're going to end this, and let's get rid of the M right there. And let's go and shorten this guy down as well. And let's go and change this to doubles so that we'll be able to see that we're working with doubles in this. So DBL. And let's change this to DBL and this to DBL as well, just so we don't cause confusion. And that means this has to be DBL and this has to be DBL. Once again, all the code is available in the description with a transcript. And change this to double. We're also going to print out the max value for our doubles. So I'm going to change this to biggest double. And I'm just going to disregard this so I don't have to. You can go and do that if you'd like. And here, to print this out as a string value, what we're going to do is we're going to change this to double and max value. And then if we want to change this to a string, we're going to go toString like that. And inside of here, put a hash symbol. And that's going to allow us to print that out. Make sure you have that last parentheses there. And let's run that and see what we get. And you can see the doubles are quite large, as you can see, but they're also not precise. So we can see right here, whenever we add these together, 981, you can see right here, 79, and we added 2 to it that time. You can see that that's going to work, but if you increase this by just 1 digit, whoops, I went and tried to do something I shouldn't do. All right, let's close this off. If you would go and increase this by just 1 value, you're going to see that those values are going to be disregarded. All right, so The whole point of this is to just introduce you to the biggest and largest numbers you can store in these different data types, and also to show you how precise they are and how they can cause you problems if you don't pay attention to that precision. Now I'll talk about floats, and we'll get the biggest float. A float is a 32-bit floating point number, and it is not as accurate as a double. It's half as accurate, actually. And we'll go float at max value, but normally you're not working with gigantic values, so you normally don't have to worry about that. And this is a lowercase float like that, and that's going to print out the biggest float that we have. We're then going to change this from double to float, and we're going to change this to float. And let's go and change this to float once again, and this to float. And then we're going to have to shrink this down because we can only work with 6 digits. See? Gets much, much smaller. So let's get rid of that. Oops. Put the 2 back inside of there. And then we're going to have 5 zeros and get rid of this. And then we can come in and add these up. So this is going to be float, and this is going to be float as well. Got all that saved, and we can execute it. Oop, have an error. Oh, the reason why is I forgot to put the F there. See, it's good. I made the error, and that's going to point out the fact that you could make that error. It's a common error. And if we run it, you can see right here, if we move this up, that it was able to add 2 to that value right there. However, if you tried to add one more decimal place, it's going to foul up, and you can also see the biggest float you can work with. But again, it's not precise if you work with that gigantic number. And there are also a whole bunch of other different types of data types you can work with, and here they are. You can also work with bytes, and you can see how big those numbers are. You can see here you have characters. Those are going to be one individual character, S byte, and how big those are, and so forth and so on. So those are all of the other different data types, aside from strings and a couple other I'm going to introduce, but those are the main number types that you're going to work with. It's also important to understand that you can convert from strings to other types with a function called parse. So let's say that I create a boolean, and I'm going to call this boolean from string is equal to. So normally you're going to be receiving input, and it's going to be received as a string. And if you want to change it to an actual other data type, this is how you do it. You go bool parse, and then let's say this is true. And you can put that in there, and that's going to convert that for us. And you're also going to be able to go int from string is equal to int parse. And in that situation, let's say it's 100. And of course, that also means you're going to be able to do this with doubles and with decimals and all these other different data types. But I can go double from string, just to give you an example. And to do that, you would go double and parse. And in this situation, 1.234. All right, so that is how we can convert from strings to other different data types, which is also a very useful thing to be able to do. So let's talk about some other additional data types you might want to work with. Let's say you wanted to work with dates and times. Well, if you want to work with a date, you use a type called DateTime. And let's say we go awesome date. And we want to define a date inside of here. So what we're going to do is go equal to new date time. And this is a date time object, 1974, 12, and 21. Probably the most important day ever in history. And we can go and print that information out onto the screen. And we can print out additional information. So let's say that we wanted to get what was the day of the week whenever that date occurred. And we can go and we can find out. And how we can find out is just by going awesome date like this and day of week. And close that off with a semicolon. You're also going to be able to come in here and change these values to maybe not so awesome of a date, but what the heck, we have to come in here and do something. So to do so, we would go awesome date, and we wanted to add, say, 4 days to that awesome date. We could do so like this. We could also, in a very similar fashion, come in and add in months and just change this to months. And let's say that we want this to just be 1. And we could also go and add in another year to it, just by going years like that. And let's just add 1 to that. And then we want to come in here and print out that information. So we can go and print the entire date out by going console and write line, of course. and this new date, and we will throw that inside of there. And to get the entire date, we go awesome date followed by date and run it. And you can see the day of the most awesome date in history was on a Saturday, and the new date based off all the changes I made are what you can see right there. All right, so cool stuff. Let's get rid of that. We're also going to be able to work with times in a similar way using what are called TimeSpan objects. So to create one, you go TimeSpan, and let's say we want to define lunchtime equal to new TimeSpan, and let's say that it is at 12:30 and 0 seconds. There we go. We just created a TimeSpan object. We're then going to be able to come in and go lunchtime, and let's say that we need to change our lunchtime. We can do so. Let's say we want to subtract 15 minutes from our lunchtime. We can go in there and go subtract and new TimeSpan. We're actually creating another object to subtract from it. There's the 15 minutes, and there is the seconds. We're also going to be able to add time. So let's say that we had a problem with our time to get our lunch. We can go add, and let's say it's an hour later, and the minutes are going to be 0, and that's that. And then if we want to go and print out our entire new lunchtime, we can go right line and new time and get the actual lunchtime. And to do so, we go to string. And toString is a function. Remember up here, we were talking about how to parse values to change them from strings to other numbers. Well, we often use another function called toString to convert other values into strings. Close that off with a semicolon, and if we run it, you're going to see the changes of time. All right, so there we are. That is DateTime as well as TimeSpan. Another thing we can work with are what are called big integers, and they are used to store very, very large numbers. But to use them, what you're going to have to do is come up here to Project and click on that. Come down here and go and click on Add Reference. Under Assemblies, inside of Frameworks, you're going to want to come in through here and look for System Numerics. See that right there? And you're going to want to make sure there's a check mark inside of there, and then click on OK. Then scroll back up to the top of all of your code, and then come in here and type in using System Numerics, exactly like that. And then you'll be able to make big integers. Likewise, even if you are on a Mac, you're going to be able to do the same thing. Just come up here, click on Project, Edit References, click on that, and just leave all selected, and then look for System Numerics. And that's right there. Put a check mark inside of there, click on OK, and the world's awesome. All right, back into the Windows world. So what we're going to do here is I'm going to show you some things we can do with big integers. Now, to define a big integer, what we're going to have to do is to define the value using what are called text literals. And you don't need to memorize all of these different things I'm saying right now. Just after I do them a whole bunch of times, you're going to remember them. And to do that, you're going to go parse like this, and then we can throw a big value inside of here. I'm not going to do much with this, just wanted to introduce you to it, and you can go ahead and play with it as much as you'd like afterwards. And there we are, so we just created one. And then we're going to be able to work with them just like any other data type. So we'll be able to go and write line and go something like big number times 2 is equal to, and throw a value inside of there. And then we'll be able to come in and say big num times 2 just to demonstrate that they are used just like any other value. And if you see it, there they are. All right, so there we go. That's a big integer. Now, very often you are going to want to format your output in specific ways, and there's a whole bunch of different formatting options that are available to you. So we will say console and write line, and for one thing, you can output information as if it is currency. And to do so, inside of those brackets, you're going to put your normal 0 like you have there, but you're going to say, hey, this is currency. All right, so that's how easy that is. Come in here and let's say you got 23.455, which isn't currency or normal currency. And I'm going to show you a whole bunch of different formatting options here all at one time, so we don't have to keep doing that. So let's say we want to also pad the values with zeros. We can do that as well. And how you do that is come in here and put D4. And let's just change this to 23. What else can we do? We can have it only show 3 decimals, like that. And then change this to F3. And throw another 5 on there, and it's only going to show 3. And why don't we do one more? Let's say we want to add commas and decimals. We can just change this to commas, and then come in, get rid of this, and say N and 4. And for this guy, we're going to say 2300. And if we execute that, you're going to see how all those work out for us. The 4 with the N4 that you see right here, that is going to make sure we have 4 spaces in the decimal places. It also puts commas inside of there. 3 decimals is going to cut off whatever is over here and round it up. You're going to see that this guy right here, D4, is going to make sure that we get 4 values, whether we have them or not, and this is currency. All right, so there's some formatting options that are available to you. And now I'd like to take a look at strings. Now, strings are going to allow us to store a series of characters, and you've seen them before. To define a string, you just go string, and we'll say random string. And let's go and give this a value. This is a string, just to keep it simple. Now you're going to be able to come in here and get the number of characters that are inside of the string, or the string length, as it's often called, just by going random string and then following that up with length. That's also a way you could cycle through a string and output that information on the screen. Let's go and copy this, and let's see some other string functions that are available to us. We are also going to be able to come in and see if a value is contained inside of a string. So we will say something like string contains the word is inside of it. You can also go like this after the comma and move that down there so that you can see things a little bit easier. And to find out if it does contain something, you just go contains and whatever you are searching for, and it will then jump back and tell you if it contains it or not. Let's go and do some more. Oh, make sure you put that last parentheses in there. All right, let's see some more string functions that are available to us. And let's go and put this down here as well, so you'll be able to see all those at one time. You're also going to be able to find the index of the beginning of the match of a string. So we will say something like, let's go and put a space there, index of is, and we'll just change contains into index of, and that's going to give us that. Let's go get some more. Let's say you want to remove the number of characters starting at an index. I'm just going to call this remove string, and to do that, we can say remove, and we want to start at the 0 index, and we want to remove 6 characters after that 0 index inside of there. Let's go and do some more. Let's say you want to insert a string. Well, let's just go and call this insert string, and to insert, you're just going to say insert like that, and we're going to say at the 10th index, we want to import the name of short and put a space inside of there. We can also come in and replace a string, and it's going to find whatever we are searching for, and it's going to change it into whatever we tell it to change it into. So we'll just call this replace string. And to replace it, of course, we're going to use replace. And what we are specifically looking for is the word string, and where it finds it, it's going to change it into sentence. We're also going to be able to compare strings. And what this guy's going to do is if the value that is returned from this function is less than 0, that means that string 1 is going to precede string 2. If they're equal, it's going to return a value of 0. And if it returns a value that is greater than 0, that means that string 2 precedes string 1. And let me show you an example here that will make more sense. Let's go compare A to B. And here what we're going to do is change this into a string. And this is a string object, and string object function or method or whatever you want to call it. And what we do here is we pass in the 2 strings that we want to compare. I'm just putting single characters in there, but that doesn't mean you have to. And if I want to compare these strings and ignore case, what I can do is go comparison dot original ignore case. Oh, we run these just to see what they look like. And there you can see String length, it went and counted all those characters. Did it contain the word is? Yes. Index of is, the very first index anyway, is 2. Remove string, you can see here. It removed the very beginning of our string. Insert a string, you can see it put short inside of there. Replace string, you can see it changed string into sentence. And here it returned a negative value. And what does that mean? That means that string A, or the letter A in here, precedes the letter B whenever we compare those two strings alphabetically. Let's now come in and let's see if two strings are equal to each other. So what I'm going to do is go A is equal to lowercase a, and this is why you'd like to compare values with and ignore case. And to do this, we are going to come in, use the string object again, and use a function called equals. And then inside of it, we will pass what we want to compare. So we'll say A to A. How'd that get in there? And get rid of that. And then we will follow that up with our string comparison. That guy right there. And then original ignore case once again. Do a couple more here. We can add padding to the left side of the screen. So let's say, or left side of the string. So we'll say something like pad left. And what this is going to do is add padding to the string as a whole. It's not going to add, like if you put a 5 inside of here, it's not going to add 5 to it. It's going to add whatever is over the total size that you define. So what we're going to do that is go pad left. And let's say that we want it to be 20 total spaces in size. And everywhere to pad, we want to put periods. We can put spaces, of course. And let's go and copy that. And we can also do padding on the right side of whatever gets printed out. Again, let's leave this be 20 and that like that. And we just change this to pad right. Go and do a couple more to finish off these strings. We're also going to be able to trim white space. So let's just change this to trim. There is no white space, but whatever, it'll work if there is. Here, random string, and just put trim inside of there and nothing, and it'll get rid of all the white space on the left and right side of our string. And we're also going to be able to make this uppercase, which is sometimes a good way to compare strings. So uppercase. And for that, you just change this to upper. And guess what? You're going to do pretty much exactly the same thing. If you want to convert every value in the string to lowercase, just change this to low. And change this to low as well. And also, you're going to be able to use the format function and to go and create strings. So we can say something like string and new string we want to create is equal to, and let's say you want to do something like Mad Libs. I don't know if anybody out there even knows what Mad Libs are, but whatever. We're just going to be placing values inside of here. So let's say we have something like this, saw a, and then we're going to throw in something else inside of there. And the next one is 2 in the, and 3 like this. Not exactly. And then after that, we could say something like Paul's going to be the first value, and then rabbit, and then eating, and then field. Not exactly the most uproarious, funny Mad Lib you ever saw in your life, but we have that. Another thing that's important to understand with strings is, let's say you wanted to have a string and it had a double quote inside of it, inside of the double quote. Well, if you have the double quote here, it's not going to know where the definition of the string begins or ends. So if you want to put a double quote inside of there, you put a backslash like that and your double quote. Likewise, you can also do a backslash, well, it's backslash and double quote like that, not double quote. And likewise, you can do a regular quote inside of there. You're also, if you want to do a backslash inside of your string, do double backslashes. You could also do a tab, and you could also do an alert. An alert inside of a string, whenever it runs, is going to go and play a beep noise. You can play around with that on your own. And also, there are things here to finish off called verbatim strings. And if you go and do something like console write, and then put an @ sign inside of there, exactly what I typed. And then you can put something like a single quote inside of there and a backslash like that. It's not going to matter because it's going to print out exactly what you typed. And you can see right there, we didn't have to use backslashes to use those guys. And there is all the output from all the other string functions that I defined in my code. And there you go, guys. That is a great introduction to C#, or at least I think it's pretty good. Don't want to overwhelm you, and I'm going to fairly quickly whip through the C# language over the next couple of videos, but I'm going to provide an immense amount of detail in comparison to my Learn in 1 videos. And then we'll move on to Xamarin and making games and Unity and a whole bunch of other different things. So just like always, please leave your questions and comments below. Otherwise, till next time.